Hello, welcome to another mathematics lesson. My name is Kingsley Linus. In today's lesson, we'll be learning about estimation. By the end of this lesson, you should be able to define estimation. Secondly, you should be able to estimate the dimensions and distances within the school. Also, you should be able to estimate the capacity and mass of given objects. Next, you should be able to estimate other things in day-to-day activity. And lastly, you should be able to solve quantitative reasoning problems in estimation. When you hear of the word estimation, what should come to your mind is a rough guess or a rough calculation. Another word that can be used for estimation is approximation. In maths, when we represent two values or two things that are approximately equal, we use this sign. When two things are equal or exactly the same, we use this sign. Estimation is the process of making estimates. Let's look at an example to find out what estimate means. Our example here says a florist is considering buying 270 seedlings at 118 naira each. The man does a rough calculation. Instead of using 118 naira, he uses 120 naira. And rather than just using 270 seedlings, he chose to use 300 seedlings. Now, 120 multiplied by 300 gives us 36,000. Now, this is a rough guess. It's an estimation. But let's look at the real value of calculating these figures, 118 and 270. So 118 multiplied by 270 gives us 31,860 naira. Now, if you observe the difference between the estimated cost and the real cost, you realize that the farmer will be safe even in the event of an increase in price of these items. Let's look at another example. Our next example says a student trying to solve a question calculates the pay of someone who works for 26 days in a month at 95 naira 80 kobo per day. Now, by a rough guess, she assumes the worker earns 2,600. So she already knows that the worker's pay is a little lower than 2,600. But here is the precise answer. 95.80 multiplied by 26 gives us 2,490.80. Now you realize that this amount is close to the estimated amount of 2,600. So estimations can give us a rough idea of what the true value is. Just like I explained about the florist in our previous example, estimation can also help us avoid errors and help us know if our answers are reasonable or sensible. Now, one important thing to note when carrying out estimates is what is referred to as rounding off. Let's find out what rounding off means. Rounding off numbers can be to various degrees of accuracy. For example, we can round off a number to one significant figure. We can also round to the nearest whole number, and so on. Now, rounding off, simply put, means making a less precise version of a number. And in rounding off, we carry out two activities, but one at a time. It is either we are rounding up or we are rounding down. Now, how do we know when to round up or when to round down? When we consider the degree of accuracy to which we are about to round off a number, then we must look at the next significant figure. If such a figure falls within 1 to 4, the numbers 1 to 4, then we round down. And when the next significant figure falls within 5 to 9, then we round up. Let's look at some examples to better understand rounding up and rounding down. For example, 95 naira 80 kobo rounded to the nearest whole naira is 96 naira. How did we get this? You realize that the next significant number after our naira or the unit naira is 8. And because 8 is higher than 4, we round up. According to the image here, when we have numbers from 5 to 9 as the next significant figure after a number we are interested in, we simply round up by adding 1 to the next figure. And so, because of 8 here, we add 1 to our 5. That brings us to 96 naira. Now, to the next example, we have 8.9 rounded to the nearest whole number. Our whole number here is 8. So, the next significant figure is 9. And for the number 9, we have to round up. So, we add 1 to our 8 and then our number becomes 9. Now, for our next example, 5.5. 5.5 is the same thing as 5.5. So, the next significant figure being 0.5 can be rounded up. Therefore, we add 1 to our 5 and then we have 6. And lastly, we have 0.353 rounded to one significant figure. Now, one significant figure, if this is our first significant figure, we have 3 significant figures in this number. So, but we are only interested in one significant figure. So, the next digit after the first significant figure is a 5. And what do we do to a 5? We add to the next number, we round up. So, our number becomes 0.40. I hope those explanations were clear. Let's go on to look at some more examples. Round off the following to the nearest whole number or one significant figure, then estimate your answer. Please note that 1 SF means one significant figure. We have 653 minus 287, 9.774 divided by 3.45, and 10 whole number 1 over 4 multiplied by 3 whole number 1 over 2. Now, to solve that, we must first round off to the nearest whole number or one significant figure. 653 can be rounded to 650. 287 can be rounded up to 290. Now, when we subtract 650 from 290, we have 360. Also, 9.774 can be rounded to 10. Here, we are considering the first significant figure. And for 3.45, to one significant figure is 3. So, 10 divided by 3 gives us 3.3. And lastly, we have 16 whole number 1 over 4. 16 whole number 1 over 4 is the same as 16.25. Now, to the nearest whole number, you realize that 0.2 will be rounded down. So, we have that as 16. And for 3.5, 3.5 is the same thing as 3.5. To the nearest whole number, 0.5 can be rounded up. So, it becomes 4. And then we go ahead to multiply 16 by 4, and that gives us 64. Now, let's go further in this lesson by considering how we estimate length and area. We can estimate distances within the school, but to carry out this effectively, we must use appropriate units. Let's consider some of these units in this lesson. First, we have millimeter. It is usually written in short as mm. Now, we use this unit to measure short lengths. For example, the thickness of a textbook. Now, it is important for you to take note of some estimates I'm going to be giving. For example, the thickness of a book can be 120 mm. Next, we have centimeter, written as cm for short. We use this for short lengths. For example, the length of a pen. I measured my pen and I got 15 centimeter. Next, we have the meter, written as m for short. We use this in measuring average lengths. For example, the length of the sides of the classroom. Now, you can measure the length of your classroom using a tape and recording your answer with the appropriate unit. The next unit is kilometer. It is written as km for short. We use this for long distances. For example, the distance from home to school. Now, I'm going to give you an estimated value of 8 kilometers. Area can as well be measured in the following units. First, millimeter square. We use the millimeter square to measure very small area. For example, the area of an eraser. An estimated area of an eraser is 120 mm squared. Next, we have centimeter square. Areas like the front page of an exercise book can be measured using this unit. An estimated value, 336 centimeter squared. A basketball court can be measured using the meter square. An estimated value for a standard basketball court is 420 meter squared. And lastly, the kilometer square is used for large area of land. For example, the land area occupied by Port Harcourt City. An estimated value is 369 kilometer squared. Let's move on in this lesson to find out how we estimate mass and capacity. Estimating mass and capacity has units as well. Let's look at these units. First, for mass, we have the milligram, gram, kilogram, and ton. For smaller masses, we use milligram and gram, and for larger masses, we use kilogram and ton. Capacity as well can be estimated using some common units. We have the milliliter, the centiliter for smaller capacities, and the liters for very large capacities. Now, with all I have said, I have an exercise for you. Try out these questions, pause the video, and try the questions. The instruction says, fill in the appropriate units for measuring the length of each of the items. Number 1, length of your fingernail. Millimeter can be used to measure our fingernail. For the distance around the earth, the appropriate unit should be kilometers. The next instruction says, state the unit of area for measuring each of the following items. Space on your desk. Centimeter square should be appropriate. The floor of a classroom. Meter square should be the appropriate unit. The next instruction says, state the units of mass you will use to measure the following items. Number 5, a mango. Grams should be an appropriate unit. Number 6, a packet of sugar. Grams as well should be appropriate. And lastly, state the unit of capacity you would use to measure a bucket. The liter is an appropriate unit. If these were your answers, you are correct. As math students, we should be able to know the size of certain parts of our body. For example, our hand span, our foot length, the length of our pace, our body mass, and so on. I'm going to just write out some estimated values of these measurements when taken. For example, a hand span can be 22.86 centimeter. A foot length can be 10 inches. The length of your pace can be 76 centimeters. And a body mass can be 70 kilograms. While the length of a pencil can be 15 centimeters. Now let's carry out an activity together. I'd like you to pay close attention as we make estimates of certain objects. The first activity, if the length of your board is 10 handspans, estimate the length of the board. Now, to make this estimate, we are going to use the estimated figure in the previous slide. The estimated figure for a handspan is 22.86 centimeters multiplied by 10. When we multiply this, we will have 228.6 centimeters. The next activity says, if Ade said the distance from the principal's office to his class is 32 paces, and your pace and his pace is the same, estimate the distance between Ade's class and the principal's office. Still making reference to the length of pace in the previous slide, 76 centimeters is an estimated length of pace. So we can say 76 centimeters multiplied by 32 paces, and that will give us the estimated distance between Ade's class and the principal's office. 2,432 centimeters. And lastly, BC weighed her mathematics textbook. It weighed 324 grams. Her school bought 96 copies of the textbook. Estimate the mass in kg of the parcel the books came in. So we have 324 multiplied by 96. That gives us 31,104 grams. Now the instruction says in kilograms. At this point, it is important to note that 1 kilogram is equivalent to 1,000 grams. So for us to find the equivalent of this number in kilograms, we will divide by 1,000. We have 3 zeros, so we move our decimal points 1, 2, and 3. So our answer is going to be 31.1 kg. Now, having learnt this much, let's consider some quantitative reasoning problems on estimation. Now, if you observe this sample very carefully, you realize that the number we have in the middle is a sum of what we have on the left and what we have on the right. Having known this, we make reference to this number. For us to find what we have here, we would round off this number to one significant figure. Now, the first significant figure here is 0.9, and the next digit after 9 is 9. So we round up. Now, by rounding up means we will add 1 to 9, and when we add 1 to this 9, it spills over, taking us to 1.0, and that's how we got our answer here. But for us to get the answer here, we divide whatever we have here by 10. So when we divide 0.99 by 10, we have 0.099. The same thing applies to the second sample. We add what we have on the left and the right to find this. And then one significant figure gives us this. And then dividing this by 10 gives us this. So to find out what we have here, since we don't have what is meant to be on the right hand side, we will subtract this number from this. And the answer is 0.03. And when we divide what we have here by 10, the answer is 0.082. I hope those samples were clear enough. Now try out these questions. I believe you are done. The correct answer to question 1 is 500. For question 2, the correct answer is 0.03. For question 3, the correct answer here is 43. And for the last question, question 4, the correct answer is 3.8. With these exercises, we have almost come to the end of this lesson. But before you go, let's look at all we've learnt in a summary. First, we learned that estimation is making a rough guess or calculation of the value, size, or amount of an object or item. When we estimate, we take a guess. Furthermore, we learned that estimation or the skill of estimating is helpful when we do not really want exact values for mathematical calculations. Next, we learned that estimation involving lengths, areas, mass, and capacity must be carried out using the appropriate units of measurements. And lastly, we can estimate the length, area, mass, and capacity of a lot of objects around us. Now it's question time. Question 1. An estimate is a or an dash of the value, size, or amount of an object. Option A, exact record. B, actual size. C, rough guess. D, real fraction. The correct answer is option C, rough guess. The second and last question. A woman's face is about 70 centimeters long. She takes 2,858 paces to walk from her home to the market. The estimate of the distance from her home to the market is option A, 40.83 centimeters. Option B, 200,060 centimeters. Option C, 200,060 kilometers. And option D, 40.83 kilometers. The correct answer is option B, 200,060 centimeters. Here is where we come to the end of this lesson. Thank you for your time. See you again in another mathematics lesson. Bye-bye.